All right, here I'm back again. I'm going to go over the notes for week 4, marking period 2, basic log properties. I'm doing it in YouTube so it sticks around longer than our Zoom lesson. I'm not going to spend too much energy on converting from form to form because you guys were really good at that. I just want to refresh your memory that your base to your power equals your answer. And when you change that to log form, you write log, and then your base becomes little. It's G's tail, if you will. Then your power is actually what it equals. And your answer comes here, or changes to here. So if I have 2 cubed equals 8, the other way to say that as a log is log base 2 of 8. It would take 3 powers for that 2 to become an 8. Okay, so we went over all of that and then we started going over the properties. Now I do want to refresh your memory when you do the properties. I also would have a list of base 2. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is my favorite, 32. And 2 to the power of 6 is 64. You could go on, you just double it each time. So another power times 2, another power times 2, another power, etc., etc. The other base that you might want to have kind of written down is 3, because it's a really nice prime base, nothing crazy. 3 to the power of 1 is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. Those are just kind of nice. They use them in SATs and standardized testing pretty quickly, so, or very often, if you will, so those would be nice. So we have 4 rules, and remember we also introduced E, so I should put E in here, but we'll talk about that later. So, well, I'll add it to this. Log base B of 1 equals 0, because anything to the power of 0 is 1. So I kind of think of it as a perfect 10, if you will. Same thing for if I had ln of 1, that will equal 0, okay? Because e to the power of 0 is 1. Okay, remember though, if I do log base b of 0, that is one of our DNEs. There's no power to give something to get nothing back. The other one that's a DNE is log base b of any negative. There is no power that's going to give you a negative of a positive base. So these are my 2 no-no-nos. And same thing for ln. ln of 0 is DNE. Does not exist, by the way. ln of negative is DNE. Now, these are my favorite rules. Log base b of b, they cancel out. They're inverses, they're frenemies, okay? The power that he has is 1, that survives. It also goes with this rule. If it's log base b of b to 5, the 5 would survive. So this is the rule that we use to solve something like log base 5 of 25. Because 25 can be written as a base 5. 25 is 5 to the power of 2. Log 5 cancel out. The power of 2 survives. Okay? Same thing with ln. If I have ln e to the 4th, ln and e are frenemies. They cancel out, and the 4 would survive. I guess that's an example, sorry. And then we have b log b. If you have the base to the power of a log, base b, oh my goodness, there's so much going on there. Those cancel each other out, and the last man standing is your answer. So 3 log 3, 3 log 3 cancel out, 7 survives. 10 log, if there is no little number there, there is an imaginary 10. Just like a square root has a 2, a log has a 10. They cancel out, and the 5 survives. So like I said, I want you guys to have a video that kind of goes through these examples, especially since you have something due this week. assessment-wise. So evaluate the logs without a calculator. Without, that's good. Okay, log base 4 of 1. Okay, sounds like it's the perfect 10. Let's look at our list. Yes, anything that's going to give me a 1 has a 0 power because a power of 0 always gives me 1. So this one should just be like, oh, that's one of my properties. Okay, also, you could do it like I do every other one. All of these, what I'm going to do is take the log that they give me, and then I want to write that same base to some power. Because I know this and this cancel out, and whatever the power is the answer. So I really want to solve, what power to give 4 to be 1, and the only power that gives me 1 back is 0. All right, this is another log and 1. Once I see log 1, I know 1 is a perfect 10 here for log. Now here comes the awesomeness. Log 5, 5, they match. Every number has a power. They don't just match, they cancel each other out. 1 is the last man standing. Then I threw in some of our no-nos. You cannot take the log of a negative. You cannot take the log of a negative. You cannot take the log of 0. So these 3 are going to be, no sir, do not exist. Does not exist, does not exist. Can't do it. And now we get into the things that you have to think about here a little bit better. Log base 2 of 4. So again, some of you can be like, okay, base 2, Ms. Freibush told me to write it down. That'll take 2 powers. Otherwise, if you forget that, you want it to say log 2, 2. Because this will cancel out and it'll equal your answer. So whatever this x is going to be your answer. Boop, boop, boop. So I'm going to take 4 and 2 to the x, and I'm going to set them equal. And this is the first time we're dealing with bases and not necessarily like algebra, like 2x equals whatever, and then just divide by 2, inverse operation. The inverse of a base is a log. So if we're going to use a log, the bases need to match. You always use the smaller of the 2. So I'm going to take 4 divided by 2. 4 divided by 2 is another 2. Now I have 2 matching 2's because 4 is simply 2 squared. So 4, I'm going to make 2 squared because there's 2 powers of it. The bases match, so I can log 2 both sides, if you will. Basically, if the bases match, the powers have to be equal here. So x will equal 2. If you need to pause the video and go back, if I went too quickly, that's the beauty of having this available. All right, log base 2 of 8. Same thing. I'm using bases of 2 because they are on that list up there, but I'm also using them because they're fairly easy to divide by 2. So I want log base 2 of 2 to some power, because that will cancel and the answer will be what this equals as long as I can take 8 equal to 2 to some power. So 2x equals 8. The smaller guy is 2, so I divide by 2. Now, 4 can be divisible by 2. We just did it over here. So I have to keep going till it's only 2's. Keep going till it's only one single base. So now it's 1, 2, 3 bases of 2. 2x is on the left. 8 is now 2 to the base of, or power of 3. The bases match, so the powers will match. X equals 3 is my answer. All right, log base 2 of 32. All right, again, I want it to be log base 2 of 2 to some power because that power will be the answer. but that only works if I can get 32 to be the base of 2. So I take 2x equal to 32. Again, at this point, you know it's base 2. You can go to your chart up here and find where 32 is. Told you 2 is a good one to write down. Or you can simply continuously divide 32 by 2. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4. And half of 4 is 2. If I did this right, it should be 1, 2, 3, 4, 5. It should be all 2's. And there are 5 of them. So 2 to the x equals 2 to the 5th. And the power I need here is 5. Now we're going to continue the journey, but it's going to go a little differently. I'm not going to actually point this out till the end, even though in class I pointed it out right away. Log base 4 of 2. I would like this to say log base 4 of 4 to some power, because that power will be the answer, because those will cancel out. If I do that, I have to set 2 equal to 4x. And this is where it's a little bit of a change. When I did it up here, 2 had the x, and 4 did not. Down here, the 4 has the x. It doesn't matter. Follow the same rules. Use the smaller of the 2 bases. Your base here is a 2 that is tinier, so I'm going to break the 4 down. 2 times 2. 2 times 2 is 2 squared. This 2 has a power as well. Every number has a power. This power is 1. So the 2's cancel out, and 2x equals 1. Divide by 2, divide by 2 to solve for the x, and I get 1/2. Now I'll point it out. Here, my base was small, and I went higher, so it was a whole number. Here, my base was bigger and I went smaller. It was a fraction. All right, I chose these for a reason. 2 to get 8 is 3, but 8 to get 2 will be 1/3. 2 to be 32 is 5. 32 to get 2 is 1/5. All right, log base 3 of 27. Log base 3 of 3 to some power. I need these to be equal. 3x equals 27. I divide by 3. Divide by 3. I get 3 to the x equals 1, 2, 3 to the 3rd. X is 3. I'm running out of time. I have time for one more. Let me do a fraction one. I have log base 4 of 1 over 16. So I need this to say log base 4 of 4 to some power. I need these to equal. 4 to the x equals 1 over 16. Well, that's a problem. I don't want a fraction, but every number can be written without the fraction if I give it a negative power. So now follow the same rules. The 1 over 16 can be written 16 to the negative 1. That tells me it's a fraction. So 4 is smaller, so I will divide by 4. 4 times 4 is 16, which is 4 squared. And that equals 4 to the x. X and, 2 parentheses, negative 1. Parentheses in math mean to multiply. 2 times negative 1 is negative 2. And that's the power I would have to give the 4 to get to be a 1 over 16. All right, my friends, please use this video to help you out, and good luck.